Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at a new form of initialization in C++11, which is really great, especially when you use it with vectors, as we're going to see shortly. So we've seen that you can use braces in C++98 in some situations. C++11 generalizes the usage of braces. So let's say we have an int value. We can put braces immediately after the int and put a value in there. Now you notice there's no equal sign, so the initialization with braces in C++98 involved an equal sign. In C++11 you're just putting the braces immediately after the name of the variable. So we can use this with everything. Let's put get rid of that blank line. We can have a string, for example. Let's call it text, and let's put in some braces. We can put hello and cout text. So this is going to work. We can use it with arrays even. So we could do, let's say, int. Let's have an array of ints here. Let's call it numbers. Put in the brackets. And if we're going to supply initialization values, we can leave out the number of elements in the array because it can figure that out. And then we can output numbers. Let's output numbers 1 to get the second element there. So this also works. You can even use it with new. So let's say we have int pointer p ints equals new int, and I'm going to put the brackets in there. Let's see. Equals new int, and here we're going to have to specify the number of elements in the array. So let's put 1, 2, 3 there. So if I just run this, I don't think that will actually build. So if we build that, it doesn't build. But if you put the number of elements in there, it does, and it works as you'd expect. Let's put in a delete and output p ints 1, which should give us 2, the second element there. So using array subscript type syntax, we get 2 again. So that works. If you use empty braces, you can initialize things to 0. So let's take this as an example. So int is a good example to take, and this works with strings and pretty much everything as well. If we leave the braces empty, we're going to initialize this to the default value, which is 0 for an int. For a string, it will be an empty string. For a pointer, this also works. So we could have a pointer, let's say int pointer p something. We could use braces there. If we want to initialize this to point at another pointer that already exists, we could put an initialization in there. Or we could, for example, we've got an int pointer here, and here's an int. So there's no reason why we can't put address value in there and do cout p something. Maybe put dereference in there to see this working. So if we run this, this is going to work. So there we've got 5, which is the value of the int that we pointed it at. But we can also have empty braces in there. It's actually equivalent to setting it equal to a new C++ keyword called null pointer. So you'd expect it would be equivalent to this. Now null is it's a macro, which was kind of a C-style macro, I think, which we've used before in C++. But the problem with this is, it's not a keyword, and you have to include a header. You know, if you include pretty much any header, it will pull in null from somewhere. But it's not a C++ keyword. But in C++11, we've introduced a null PTR type like this. So this is not equivalent to an int. You can't cast it to an int. It's a new keyword like true or false, which we can use specifically for initializing pointers. And if you do this, it's equivalent to saying, let's put a comment in here, equivalent to int p p something equals null ptr. So that's a new keyword for initializing pointers, but you can still use null if you want to. And if you output this using cout, it will look like it's pointing to memory address 0. I'm not sure that the implementation of this has been made fully consistent across all compilers, but it's going to be good practice now to use this rather than the null macro, although there's no harm is going to come if you keep on using null, of course. Whoops, got an extra return statement here for some reason. Oh no, it's just Eclipse being funny. Okay, never mind about that. So empty brackets initialize things to 0 values. It even works with an array. Well, 0 values or whatever the default is for the type. So let's say we have an array of numbers here, and we've got, let's say, 5 values in. Let's call this numbers 2 or something, numbers 1, I don't know. So if we output any number in that array now, it's going to be 0 because we've initialized them all to 0 with these empty brackets. You can even use it on classes under some circumstances, basically under the same circumstances that you could have used curly brackets in C++98. So let's say we have a struct like this. I'll make it an anonymous struct, although we could give it a type and declare a variable that way. And we'll declare a value s1. Let's say we have int value and string text in there. Previously, in this situation, we could have said equals and put some curly brackets in, put a value in and some text. And that would have worked. So if we output something from here, we could output s1.text, and that works. In C++98, you can miss out the equals sign here. So again, you can use the same, consistently, the same type of braces initialization to do this. Now, did I say 98? In C++11, you can miss out the equals sign. C++11 introduces a really simple way to initialize variables in classes, but we're going to look at that separately. But here you could use braces or even an equals sign to assign this a value, which you couldn't do in C++98. And then every object will get this value initially set to this, but we're going to look at that a bit more in a separate tutorial because there's more to be said about this. And we have some new keywords as well, which we'll look at. This doesn't build because as soon as you do this, you lose implicit constructors. And now to get this to work, I'd have to define a constructor that took these two parameters, and then this brace syntax would work again. But as we'll see in a future tutorial, in general, you can do that. You can initialize things. You just have to be aware that this isn't going to work anymore. But this is a limited use anyway, because if we had these private, I don't expect that to work. So this doesn't build. So it only works in the same situation that it worked in C++11. Finally, we come to the most utterly amazing thing, which if you're used to using vector, I'm including vector here, using standard namespace, and you're used to initializing it with pushback, you'll be very, very pleased to know that you no longer have to do that. So we could declare a vector here. Let's make it a vector of string, and I'll call that strings. And then we can use the braces, again, immediately after the variable name, to initialize this with values, which is really amazing. So let's do cout strings and output. Let's output the last one there. This actually works. Now, if you think about it, it's a little bit puzzling that this works because, okay, with an array, with this kind of thing, or this kind of thing, C++ only has to shove the right numbers into the right bit of memory. But here something much more complex is going on because vector is a complex data type, and vector is deciding how to store these values. So somehow there has to be a mechanism to tell the vector which values to put where, how to actually use them. And that mechanism is actually very, very simple, and you can implement it in your own classes. And we're going to take a look at that in the next tutorial. So we're going to look at the initialization list in the next tutorial, which is what this is. And it can really save you a lot of time, especially if you're working with container types, or you could use it for methods that have variable length arguments, as long as they're all the same type or a related type. Okay, but that's it for this tutorial. It's well worth just practicing this, trying it out yourself. Once you've typed it once, if you're already by now reasonably familiar with C++, then this sticks in your mind pretty well, I think, especially once you start using it. But it's worth just typing out some of these, because also your compiler may or may not support everything that I'm telling you in this section. Hopefully, if you're lucky, you've got a reasonably new C++ 11 compiler. I'm using the free GNU compiler here, and as you can see, it supports all this. But if you're unlucky, you might get caught out and find that the support is a bit patchy. But anyway, so it's well worth trying this stuff out, seeing if it all works. Okay, so until next time, happy coding.